In this video, we'll explore Euclid and the Elements. We begin in the city of Alexandria, which was founded by Alexander the Great and made the capital at that time. While he went out to conquer the world, Ptolemy ruled, and the city thrived under his rule. It remained the capital of Egypt for 1,000 years. During that time, the University of Alexandria was founded, and it brought together all the fundamentals of Greek learning, science, art, and literature. And really, it's what we can attribute how our universities are formatted. Within the university, there were lecture halls, there were museums, there were labs, and there were a lot of books in that library, which was holding more books than what could be claimed by many at that time. At one point, Euclid became the head of the Department of Mathematics, and Archimedes became one of the notable students from the university. While serving at the University of Alexandria, Euclid wrote The Elements, and The Elements are considered to be one of the most popular books. It brought together a lot of collections of work that were done by previous Greeks prior to Euclid's time, and some of it may have included some of Euclid's work, but we know it definitely included a lot of others' work. No book has been translated as much except for the Bible, but there is no original copy from that current time. It included works such as Law of Cosines, the Pythagorean Theorem, Fundamental Theorem of Arithmetic, and Proof for Infinite Number of Primes, as well as irrational numbers. It's important because it's considered such a masterpiece in the application of mathematics. It had a small set of axioms that provided a lot of results, and it provided a lot of mathematics text and context for them to be based off of. And the axiomatic approach and rigorous proof remain one of the foundations of mathematics to this time. So what does the title mean? In early Greeks, they defined elements as the deductive study of learning or key to theorems that are of wide and general use in the subject. It's considered like a relationship of the alphabet to the language. And it's important to recognize this is not all of geometry known at the time, it's just some of the foundational concepts that they did know. He did write many other books in geometry that are related to other geometry concepts. Now, one of the things that are somewhat attributed to him is the Euclidean Algorithm, which states that if we divide the larger of two positive integers by a smaller one, we can then divide the divisor by the remainder, and we continue until there's an exact division, and that will be the GCD, the greatest common divisor of the original integers. So let's take this and try it. 45 and 27. So if I take 45 divided by 27, I get a remainder of 18. I take 27 to divide by 18, I get a remainder of 9. 18 divided by 9 is a remainder of 2. That means that if I look here, I divided by 9 that last time, and it gave me an exact solution, so my greatest common divisor is 9. Now when we look at the postulates and the axioms that Euclid used in the Elements, we have two different lists, each of them with about 5 axioms and 5 postulates. And the way that the Greeks considered this to be different is that when the Greeks looked at the postulates and axioms, they considered axioms to be self-evident, assumed statements about something, whereas a postulate was a self-evident construction. That's one of the big things. A second thing is that the axioms are assumed to be common to all sciences, whereas a postulate was an assumption that was to a particular science. And last thing is that the axioms are an assumption about something in both obvious and acceptable to learn, whereas a postulate is an assumption of something that is not necessarily obvious or acceptable to the learner. Now, one postulate that causes people to have some issues is understanding what is meant by postulate 5. If a straight line intersects two straight lines so that to make interior angles on one side together with less than 2 right angles, these straight lines will intersect if indefinitely produced on the other side are together less than 2 right angles. So what does that mean? So if we look, the idea, if we construct 2 angles on the same side of 2 lines cut by a transversal, if we have the measure being the sum of 2 90-degree angles, i.e. 180 degrees, the lines never intersect. if that measure is greater than 90 degrees, greater than 180 degrees, we know they intersect on the opposite side. And if it's less than 180 degrees, we know they intersect on the same side as those two angles. And that's the concepts of Postulate 5.